if I pay you money, if I do a normal transaction, it doesn't matter if you can process a gazillion transactions in that network. What matters is how fast you receive the money. And that is what we call as time to finality.
What is the trade-off that you guys have made in terms of application level composability within Pod Network?
This demonstrates multi-chain in its logical next step.
Welcome back to The Rollup, your home for technical talks and open conversations that shape the modular future. Nothing on today's show is to be construed as financial advice. You can see our full disclosures list at therollup.co/ventures. Sit back, relax, and enjoy today's episode after a quick word from some of our awesome partners.
Redstone modular oracles are available on 50 plus chains, trusted by over 100 clients and over 6 billion in total value secured. Visit redstone.finance to find out more. All
right, ETHDenver. We're here with Shresth of Pod Network. Welcome to our studio. Welcome to ETHDenver.
Thank you. I'm very excited.
It's a good day to talk about blockchain design. And I think we were just speaking about, prior to jumping on air, about consensuslessness. And I think it'd be helpful for you to give us a rundown of your perception of blockchain design leading to your idea around the double spend problem and kind of why consensus has been important, and then leading into kind of how you guys think about it now.
Yeah, definitely. So, consensus have been almost analogous to blockchains since, our first, Bitcoin era and the whole proof of work. We've been almost thought of blockchains and consensus as the same thing. And then with all the proof of stake, and the idea with blockchains or consensuses, currently they take transactions as input and outputs them in this totally ordered log. It's almost like processing the traffic of the whole world in a single threaded machine. And with Pod, what we're doing is we're proposing a new design where the decentralized system doesn't have to be the single threaded machine. It can be completely parallel or asynchronous. And it seems that, the double spending problem, which is what you need, which is what kind of Bitcoin was selling for, right? That, okay, you want to build this decentralized peer-to-peer payment network. And to solve that, you need to solve the double spending problem. And for that, you need proof of work. But it seems that you don't need the full power of consensus. It's a bit too powerful, and that's why it's a bit slower. While what you can do is you can still build it with something we call as local ordering, and having the base layer as completely consensusless, where transactions don't get a fixed index assigned in the system. Yeah, so that's kind of a high level. But maybe I can go deeper.
So I like thinking about it for the smooth brains here. It's like when I go to Starbucks to buy a coffee, the entire world doesn't need to, all of the world's nodes don't need to redundantly rerun my transaction and agree upon it. What is more impactful is that those who are a part of this transaction in this network, they need to come to a agreement on this, on the changing of balances, and that just becomes much cheaper. And it's like local consensus oriented, less so global consensus oriented. But you're actually taking it a step further and saying, like, you don't even need the idea of local ordering necessarily as much as you do. So I don't know, is that the right way to think about, like, on the left curve side? Or
yeah. So first step to think is if I pay you some money and if I pay somebody else pays somebody else money, like, those are two independent transactions, right? They should not be blocking each other. The only case where these ordering matter is when I'm trying to double spend. And that is enforceable without needing a global consensus. But most of the traffic of blockchains are independent, right? Like, transactions do not depend on each other. And this is not something that is enforced on the consensus at the moment. And everything is paying the cost of blocking the whole world computer, which should not be the case.
I think this demonstrates multi-chain in its logical next step. Like, there's a logical progression where, we had one blockchain, Bitcoin, and then all of a sudden there was ETH. And, they were arriving, and processing blocks. And then ultimately we got more and more ETH killers or alternative layer ones, added more chains to the ecosystem. And progressively people came around to the idea that this world is going to be multi-chain. Take that all the way to its logical conclusion, and you have every user has its own rollup. And that sounds like totally mind-boggling, because people are like, why would I run my own rollup? But that's just the idea that I have my state, I compute transactions over my state, and then whoever I'm interacting with or processing, commerce with, I agree to some sort of change in state transition between our state. And so, initially the word that I would use to describe that agreement would be consensus between, between me and Starbucks, right? If I'm buying a coffee, you take money out of you put it in theirs. We have to come to an agreement on the balance change of those two accounts. Would you describe that as consensus between those, between Starbucks and I, or is there another way that we should think about the relationship from a transaction point of view of that purchase?
Yeah. So consensus in a simple term for me is like when two people have to like agree on something. And if you look at even your Starbucks example, actually the one receiving the money doesn't have to agree on, if the person sending the money is actually sending it. It just has to be convinced that the person spent the money, right? So there is it's still not a consensus between the two parties. I'm sending the money, and if there's multiple parties sending the money to the same Starbucks account, there is no consensus on which payment came first, right? Because as long as the balance is the sum, it holds. But the idea you mentioned about these micro chains or having everybody being their own kind of roll up is kind or their own chain is very, very interesting. And I think that's one way to think about it is everybody maintaining their own local order and somehow, it's these micro chains and still being able to use the base layer to do composability and transact across each other.
Yeah. And I think people do sort of have to unlearn a lot of the way that we traditionally think about blockchains. Coming in, it's okay, I make transactions on a blockchain, but I think we have to have a mindset shift from a chain-centric view to more of a quantum mindset, where it's no longer just in parallel, it's everything unpacked and modular to its fullest extent. And you can even think, let's call each of these little modules pods,
yeah,
right? And then pods are interacting with other pods and they're communicating state to one another. And they don't need some sort of global ordering mechanism. They just need to acknowledge that there's a change in state, right? So when you do have a change in state, how do you broadcast that change to the parties that need to be aware of that change?
Yeah.
It doesn't need to be everyone, but it needs to be a certain set of parties in that network.
Yeah. So, as in any kind of blockchain network, right, we also have validators, right? And these validators maintain some local state. And the trick is when I want to send a transfer, let's say I'm going to transfer money to you, I can basically just send my transaction to these validators and they just locally acknowledge if they have not seen a double spend, and that is already sufficient. And they just send you a quorum that, okay, there's enough acknowledgement. And this is significantly different from blockchains because in blockchains or in consensus protocols, these validators have to talk to each other and require quadratic communication, which is super slow, and that's the reason of the bottleneck. With pod, you can really achieve this one network round trip latency or finality, which is extremely fast and snappy, like we are used to with Web 2 applications today.
I understand that the technical breakthrough here, to kind of succinctly put it, is that the removal of transaction ordering then equals a much more performant network where there's much just lower latency, cheaper, just better overall. But there are also scenarios where I need to have transaction ordering for MEV or for, application-specific sequencing as being a large topic in the technical community. And you mentioned earlier this idea about commutative property, right? Where 2 + 3 is 5 or 3 + 2 is 5. But there's situations where that is true, and there's also situations where if I have my transaction before or after somebody, it impacts the result of my interaction on chain or on pod. So how do you reconcile the different types of transactions that do require ordering within pods, and then those that don't? And how does that be solved in your design?
Yeah. So thanks for bringing this up. Again, so some things are commutative and some things are not. And it seems that a lot of applications that are currently built on blockchains are not thought from the commutative perspective. But the commutative designs are actually quite interesting. So for example, you have different DEX designs. So you have Uniswap, right? Uniswap v2, the simple AMM, and that is actually not commutative, right? As you said, there's an MEV between like if I order the transactions. But then if you look at CowSwap, which uses batch auctions, now because it's a coincidence of warrants and it's using this batch auctions, orders within the batch is actually commutative. And similarly, you can do like limit order based DEXs where certain operations now become commutative. So the idea is if you can push more and more operations to this commutative design, they will leverage this like very fast execution. But then what we can do is you can still provide ordering for the things that need ordering. But everybody else does not have to pay the cost for it. So it's like async await. Like, when you design, if you're a programmer, you're using like, parallel computers and different processes, you use async await where you say, I want to wait for this thing to happen. I want to pay for the extra cost of ordering. And you can apply ordering or consensus posterior. So by default, everything is parallel. If I don't need ordering, I go through commutative operation. And whenever I touch something that needs ordering, that is conflicting, then I apply consensus. And then there is, we have some ideas where applications can build their own ordering gadgets. So I can choose to use a centralized sequencer or some kind of full consensus protocol or just a multi-sig, whatever I want. And this can allow these applications to capture the MEV as they want. So if they do up operations which are non-commutative and they want to capture MEV, they can decide how they want to do it.
Yeah. Now, a lot of the validators on a network, proof of stake network like Ethereum today, MEV makes up a rather significant portion of the revenue that those validators bring in. In Pod network, all of the MEV is captured at a layer above the validators. So how do you incentivize validators to validate transactions?
Yeah, for us, the base layer, so currently we feel that, blockchains are just tackling such a small part of the internet traffic. And it's like a zero-sum game of just capturing each other's MEV. But once you unlock this pod layer where it's like you can get so much more traffic about even like Web 2 traffic that's out there on Web 3, there's going to be much more potential to capture revenue for validators from the gas itself. But then applications will also have a way to capture their users' MEV if they want to.
Okay. Let's just, thought experiment. Like, suppose there's some, non-financial type of application, like a traditional Web 2, maybe social media or something, or, there's a broader theme that a lot of founders that have been in the space for a long time, would like to see this idea of user-owned internet. Now, in that world, like, the internet, we send packets to a server, they send it back, and we get our information. How would a user-owned internet work in something like Pod Network?
We actually want the experience of the user-owned internet to be as close as the existing internet, right? And that's one of the reasons why we're not getting this global adoption is using blockchains are basically super difficult, right? And it's super slow. And this is one of the key things we are targeting is can we get the UX of Web 2-like systems, but with the user-owned internet, with the decentralized primitives. And the key thing there is you want the underlying layer to be Byzantine fault resilient. It has to be open. It has to be censorship resistant, but still maintaining this like very fast, very snappy latency for finality.
And so one of the properties that makes blockchain extremely different from traditional finance and is one of the biggest selling points of blockchain is composability.
Yeah.
And right now we're seeing the explosion of a lot of different chains because of different requirements for customizations, desires for builders to be sovereign in their execution, noisy neighbors, etc. When you're thinking about composability within Pod, in terms of the applications built on Pod, because it's not necessarily a blockchain itself, what is the composability improvement from the design? Or what is the trade-off that you guys have made in terms of application level composability within Pod Network? And then how does that also extend to other chains outside of Pod that aren't necessarily following the same design as you guys?
So the way, I just think about like the current scaling solution and with all the rollups now is like you have this single threaded machine, which is Ethereum, and then you're sharding the state completely into like parallel computers, which do not have a way to talk to each other.
Which are like rollups.
Like rollups, exactly. And that is breaking the composability completely, right? And then you have different solutions, right? You have either something like Espresso, where you again put it back to a single consensus, but that will have the same bottleneck as the base layer. Even like the situations with the native and the base rollups, my feeling is it was going to have the same bottlenecks as the base layer if you put everything back to the base layer. Or you have like these bridges, but they use some kind of like, again, like a middle consensus protocol that you have this additional trust assumption. With pod, what we're doing is, as we were discussing, right, the base layer is completely asynchronous, right? And then you have these applications which are providing their ordering gadgets. And those are kind of the analogous for like rollups here, right? And because the base layer could already have like transfers and a lot of commutative operations, even when you have these ordering gadgets on top, these commutative operations across these ordering gadgets still can use the base layer and can be very fast. So if I have, let's say, a unichain sequencer and let's say another like OP stack based sequencer for some other dApp, a transfer across them will use the base layer and will be commutative, which means it's going to be very fast. So that's how we think about kind of scaling blockchains or scaling Web3 without breaking composability.
Innovating finance, global, institutional, and on-chain. Deep liquidity to drive capital efficiency. Now maximize yields on institutional-grade liquid staking with METH. Unlock $1 trillion of capital via Bitcoin. All of this secured by Mantle's treasury of billions in stables and ETH capital pools. This entire ecosystem is coordinated by a vast network of seasoned VCs that are aiming to create the next generation of banking and financial technology. This is Mantle.
So the app layer within pod itself can still be composable regardless of if there's a application that requires transaction ordering to some degree and one that doesn't.
Exactly.
And then externally outside of pod itself, you can still use that commutative layer to interact with other chains which require transaction ordering because of their nature, and they can still compose with pod.
So I was talking more about the first part where interaction, but you could essentially interacting with something which is outside pod.
Yeah, because isn't that where the problems would persist though? Like if I want to bridge from a chain that is a blockchain itself to pod and bring assets to pod, then yeah, like how does that work? Because if you guys, yeah.
So that is an easier problem to solve actually. I mean, I'm not talking about the ordering gadget state, but I'm talking about the commutative state on the pod. If you want to bring it to Ethereum, for example, and this is what we are already doing with a lot of applications. A lot of applications we're seeing actually want to use pod as a very fast layer and do things and then settle on Ethereum, right? And this could be like, PySquare, as we were talking earlier, proof markets or other kind of batch auction protocols. Limit order-based DEXs. And the basic primitive is pod provides the certificates that a transaction is finalized, which is the quorum certificate. You send a thing and you get the certificate back. And the certificate is very easily verifiable on Ethereum. So I can convince Ethereum that the transfer happened, and vice versa. I would have to probably have like a light client of Ethereum running on pod to convince the state of Ethereum on pod.
Is it almost like you guys are providing this like assurance that transactions are finalized, almost like a pre-confirmation, and then settling that to Ethereum. And so is it fair to think about pod network almost as like, a network of pods or a network of rollups, and then ultimately these rollups do settle on an L1?
So one of the fun factors, we came up with pod while we were working with Flashbots to kind of decentralize the Swav layer to do this PBS auction, because there is no existing L1, L2 that can actually decentralize this auction protocol. So it was kind of inspired from this pre-confirmation idea. But then the key thing is you don't need to put it on a blockchain, because if you put it on a blockchain, you will lose all the benefits of like this low latency and low cost, right? If you at the end order everything, you will lose that. So you want it to be unordered. You want it to be very fast, and you only want to put things in a chain or in an order when you need to.
Now, so how do you guys prevent against spam on pod?
So we'll have gas, and we have some very interesting idea of building like streaming gas, where it's like currently with blocks, the gas is very discretized. With pod, because there is no blocks, gas is more smooth, and there's like ways to kind of use gas as a load balancing tool as well across validators. So we have some of those ideas, and it's going to be similar to how we have existing networks.
So we have this race to like infinite TPS happening right now, where like you have one, I think like somebody's gonna say they have 100K, then they have 200, then a million. And like, it's just it's not really a metric anymore of value. Like, what is your North Star metric for your performance of pod? Like, what is the
I think TPS is a wrong metric. Okay. Or GPS or whatever, gigagas or whatever, because let's take a step back, right? If I pay you money, if I do a normal transaction, it doesn't matter if you can process a gazillion transaction in that network. What matters is how fast you receive the money. And that is what we call as time to finality. Somehow TPS became this like big metric because blockchains were extremely narrow, and there was this like kind of blocking process and queuing, and that's when TPS makes sense, because TPS allows the queuing to kind of dequeue faster. But then once the network is asynchronous, it really, the time to finality is the critical thing, because at the end, the user only cares about how fast the transaction get confirmed. And we achieve time to finality, which is responsive to the network. So if your network has a gigabit level, 200 millisecond throughput, then you will get your transaction finalized in that network round trip, like whatever your network supports.
So is your only limitation on transactions which do not require local ordering on pod the speed of light then?
Like, that's why we call it optimal latency and optimal throughput.
Oh, okay.
So it is literally bottlenecked by the speed of light, and we have some tricks to like add additional assumption on the client and use like these tricks that Web2 services have to even like bypass those limits. But we can get back to it in
those
maybe the next podcast.
Under the ocean that are like this big, but process the entire world's data.
Yeah,
it's kind of crazy. What are the net new ideas that are unlocked because of this? Like, I find it great and fun, and I know Robbie enjoys to go into the weeds, but, if this doesn't bring us anything new to the space, then we're just kind of building more in for the sake of it.
So I was talking, for example, in the start about building fast marketplaces. So marketplaces is a primitive, or these auctions, right? You cannot do it in any existing L1 or L2 because they don't provide the relevant censorship resistance guarantees. And auctions actually come up, or marketplaces come up everywhere. So you have proof marketplaces, right? A lot of them are coming up. And then we have order flows, right? Like cow swap, limit orders, intent layers. But then we also have blockspace marketplaces. And essentially, if you look at Web 2, all of the revenue comes from these fast auctions of like advertisements. All of these marketplaces, we don't have a primitive to do it. And pod is this one layer which can enable this. But then I think a lot of applications that we couldn't do on top of blockchains just because of the throughput and latency limits. Like, for example, we have a Minecraft running on pod. Like, it's just an internal thing, but maybe we'll make it public sometime. And you cannot run Minecraft on Ethereum. Like, can you build crazy stuff on that? With pod, you can do it. So you can build like fully on-chain games that have the UX. You can build decentralized socials that have the same UX as like Twitter or Instagram. So yeah, these are some of the things that come to my mind.
No, I'm not sure we're competing with Ethereum L1 anymore in terms of our competition, but more like Solana or Base or whomever, right?
Yeah, I mean, we want to even expand the space, right? Like, we want to take the traffic from Google and Facebook and Insta. Like, we don't want to be the zero-sum game of like who takes that 1 million users that we have, but can we get to the next batch of users in the Web3?
At that point, you guys are looking at centralized companies that are also like serving, these user intents essentially, or requests. Like, the idea that, no longer do we have to re-execute all these transactions, across the entire all the nodes in the network, but there's still, centralized alternatives, right, that operate very, very quickly. So, like, are you guys ever going to be able to get to the point where you are faster than a Google? Or if not, like, how do you what do you optimize? How do you compete with those people?
Yeah. So, I mean, a centralized thing, a decentralized thing cannot be faster, for sure, than a decentralized alternative.
Yeah, Rob, come on. So what's the advantage?
But you can get
very close in terms of latency. You'd only be paying additional on terms of throughput. And with additional, like, for example, TE assumptions or additional security assumptions, you can get very, very close. The advantages, though, are a lot, because now you can build global applications which are intercontinental. You can coordinate systems which could not coordinate before, right? I could pay from here to somebody in Nigeria with like 200 millisecond finality. I could include payments in API calls, and a lot of things that existing Web 2 could not do, you could now do it.
Come on, man.
So like
Lighten up a bit, all right?
Traditionally, like fintech, right? Like a Cash App or a Venmo or a Revolut. Like
That would not make sense. Like
that would not make sense to do on Pod.
Yeah, that would not make sense to be on the existing Web 2. Like it would be on Pod for sure. Like everything outside, like, doing like a direct peer-to-peer communication would basically should you be using some kind of decentralized internet.
I, for one, am giga bullish. Thank you for putting up with our pointed questions. Let's just lighten it up a bit as we close out here. Can I have 2 predictions for crypto in 2025 and any alpha on Pod, testnet, mainnet, how our community can get involved?
Yeah, the predictions on general Web3.
Yeah, just 2 or 3 predictions about crypto in 2025.
Putting the guy on the spot here. What are you doing there?
We need some normie-friendly content.
I want to be optimistic and say we'll see some more real use cases that adds value to people. We have not seen them so much, and I think we'll see it in 2025, and maybe Pod will make that happen. And for our alpha on Pod, we have our DevNet. If you're a dev and you want to try it out, reach out to me on Twitter, and we will be releasing some very cool application, fun things to just try out, build, and hack on it in the next month. So, yeah.
I got a prediction. I think we're going to see at least one consumer-facing marketplace on Pod. The decentralized Uber, right? Every Uber around here in Denver costs me at least $10, but then I see it pop up on the screen when I'm driving or when I'm like, and it's like $5.
LFG, we need to make it up.
You can't get an Uber for less than $5. They charge you 10, but then they give the Uber 5. Who's getting the other 5?
We need to make that marketplace.
I mean, it's not the Uber driver. Give him the other $5.
Thanks for your time, and I hope you have a good time in ETHDenver. Appreciate you coming on.
Thank you. It was a pleasure talking to both of you.
Thanks, guys.